Over the last decade, GPU compute power has grown 80-fold, yet memory bandwidth has only managed a 17-fold increase. This divergence creates a critical bottleneck for modern AI. This paper explores the hardware challenges facing large language model inference and proposes 4 architectural directions to bridge this widening gap. To understand the problem, we must distinguish between the 2 phases of inference. While the pre-fill phase processes inputs in parallel and utilizes compute efficiently, the decode phase is where performance collapses. Because it generates tokens sequentially, the hardware spends most of its time waiting for memory rather than computing, leaving massive GPUs underutilized. This memory bottleneck is being exacerbated by the very architectural trends driving AI progress. Mixture of experts models blow up memory requirements, and reasoning models generating long chains of thought extend the duration of the memory-bound decode phase. The hardware crisis is not just about current costs, but also about the viability of next-generation model serving. To solve this, the researchers propose moving beyond standard GPU designs toward 4 specialized hardware solutions. First, the paper suggests high-bandwidth flash to handle the massive size of frozen model weights, offering 10 times the capacity of standard memory. Complementing this is processing near memory, which places logic chips adjacent to memory banks. This approach captures the bandwidth benefits of processing in memory without the severe programming complexities and thermal restrictions of trying to jam logic directly onto memory cells. For extreme bandwidth, the authors point to 3D stacking, where logic sits vertically on top of memory, usually a heat nightmare, but viable here because inference chips can run at lower voltages. Simultaneously, they call for redesigning interconnects to prioritize the frequent, small messages typical of inference, rather than the large bulk transfers used in training. Implementing these architectures requires a fundamental shift in how the industry evaluates hardware. The paper argues that the era of chasing peak flops is over for inference tasks. Instead, future hardware must be judged on performance per total cost of ownership and energy efficiency, as these factors now dictate the economic feasibility of AI deployment. Current GPU architectures are hitting a wall, but by embracing flash memory, near-memory processing, and 3D stacking, we can build the specialized infrastructure required for the next generation of AI. For more insights on AI hardware evolution, visit emergentmind.com.